All right. How's the audio, guys? I think we are live and doing well. How's it going, everyone? Hope you're doing fantastic on this wonderful Friday. Uh, Today, we're going to do some two-sided machining. I have no idea how it's going to go, but we're just going to wing it because this is honest CNC. If you have any ideas for things that we can machine that are two-sided that'll fit in a 1-inch thick piece of stock, let me know. Otherwise, we're going to roll with a random banana model that I can find on Thingiverse um, and go from there. So this is all stemming from a community challenge that we have running in the Carbide 3D forums right now. Let me pull that up, actually. Um, so right now, we do sort of seasonal or monthly challenges where there's a different theme each time. And this time, it is two-sided machining. So if you make something using two-sided machining, you have to mill an indexing feature. So either like a pocket that receives your flipped object or two pinholes or just any machine locating feature, not just like flip and hope for the best. You can be eligible for a prize that includes $200 on the Carbide 3D store for first place, $100 for second place. There is a, let me zoom in a little, $100 for just favorite and swag. So that's why I decided that two-sided machining would be a good topic for today. So let's get started. So today I'm going to be using MeshCam. The principles that I'm using apply to any other 3D CAD CAM program, so Fusion, anything from the Vectric software library. So I guess I'm going to switch over to the CNC cam so I can measure my stock and also pull up MeshCam. So let me rearrange my interface right now. And then where is MeshCam? MeshCam's over here. We'll throw you over there. So let's see. Guitar neck would be great, but it's a little too large and it wouldn't fit on the stock Shapeoko I have right now. And it would also take way too long to machine in the duration of 1 hour. So let me go to Thingiverse. I am going to search for something easy. Again, if you have any other ideas, you've got about 15 seconds to change my mind. We're looking for a middle-of-the-road banana model that I can actually use on a live stream because it's not non-commercial. So let's check this one out. License CC, check. Not. So I'm downloading the, they dropped the A there, but that's okay. We'll save that file. And then let's bring this into MeshCam. So we did a little primer on MeshCam a couple episodes ago, but MeshCam is just a really simple way to bring in a solid model, do some basic manipulations on it. You can scale it, rotate it, whatever, and then generate toolpaths from it. So this is sort of like the opposite of Carbide Create. It's purely for 3D, and let's see. All right, so first thing we do when we bring in a model is figure out how large it is. It's 8 by 8 and change, 5 and change by 2 and change. That's way too large for the stock I have. I'm using some wren shape, which I think it's 3 by 5-ish. It's never exact. So I'm looking at 2.9 by 4.9. And let's check thickness because it's very important. 1.03. So actually a little more in this dimension than we expected, which is good because I think when I scale this down, the height's going to be the limiting factor. If I screw this up, the backup is a 1.5-inch block of HDPE, but I'd rather not jump into that because it's going to take a little longer to machine. So let's machine from the top, from the beginning, file units in inches, hit OK, and I'm going to have to scale this because this is just obscenely large for the tiny bit of stock I have. So let's do a uniform scaling, knowing that it was about twice as tall in the z-axis as what I can accommodate. I'm going to bring this down to zero point 0.4 uniformly, so 40% of the original size. And then let's see where we stand now. So in the x direction, we're under 5 inches. Y direction, we're under 3 inches. Great. Z, we are under 1 inch. Perfect. So now that we have a model that will fit within our stock, let's set up our stock. So in the stock size field, I know for a fact that it is, I can just round up actually. I can call this 5 inches. I can call this 3 inches. And for Z, that I will input as exactly as I can. It was 1.029 inches. And I don't want these values to change because if I start adjusting the margins, these values might auto-adjust as well. So I'm going to lock in the stock size and just center. Actually, I think I just undid that. Anyway, everything, the model should be centered within the stock, and let's check that. So underneath the model, we have a little bit of margin. Above the model, we have some margin, which is totally okay. So now we have a banana model represented within our stock volume. And do I want to machine it this way? This way is fine, I guess. So I think the next step is to figure out our supports, because we can't just machine away everything, because as soon as I punch through the halfway point from the other side, after machining it the first time, our stock is just going to fall away from the banana. So let's see, supports. I'm going to make these let's go 0.3 inches. Support width is 0.3. We'll go middle of the geometry. We'll see how that goes. Mesh cam is not technically under the Carbide 3D group, but our CEO, VP, Rob is the creator of Meshcam, and so Meshcam sort of is affiliated with Carbide through that. So we're able to offer it for anyone who purchases a Nomad, as well as it's compatible with all of our machines. So that's the deal with Meshcam. So let's try dropping in some supports. I'm going to throw one there. I'm going to throw one. Nope. So if you right-click, you can delete your most recent support. I want the support to terminate just on the geometry itself. And I think that's not going to be enough support. So I'm actually going to throw one more support here. So these supports are some things you're going to have to sand away or remove after you machine them. And with a material like RenShape, it's not a problem. You can sand it down really easily. For more complicated materials, it could be an issue. Actually, I'm going to backtrack here. So if you look at this geometry right now, it's not the most optimal for machining a banana. The little stem here is really close to an edge. The middle of the banana is too close to one edge. If we rotate this banana like 15 degrees, I think we can have a little more margin all around, because I'm not going to machine away the entire block. I think ideally we have something like that. Oh, that is terrible. But, okay. Ideally, we have a banana that's sort of oriented more. That's still not really great. But closer to here and here, little more margin here, plenty of margin here. We might even shift this down a little bit. So let's go back into our model setup. So I want to rotate this. Well, I got to cancel the support dialog first, I think. So about the z-axis, let's try 15 degrees. Incorrect. -30 to rotate it backwards. Okay. better. And I think I just broke my stock, so let's change that again. 5, 3, 1.029. Enter. Everything looks centered. Hit OK. All right, so now, still not quite centered. I'm going to lock in the stock size and then change my margin in the, which axis is it? Y axis. So you can actually see the back margin of this. It's not a lot. So we'll up that to 0.5. Hit OK. And now the banana is a little better centered. Now we can redo our supports. So do I want to delete existing supports? Yes, they're currently in the wrong position. So let's redo this. Support here. Yeah, I like that. Let's throw one here and one here. That looks good. So now when we machine this out from both sides, these supports should hold the banana in place as we machine around it. All right. Let's go down the list. Is there anything else in these settings that I want to change? Distance around the geometry to machine. 1/4 inch is plenty, I think. I think I'm actually going to machine this with an 1/8 inch ball end mill because this is wrench shape. I can blow through it pretty fast. So I'm going to machine a smaller margin around the geometry. So let's go 0.18 inches. Let's see if there's anything else we need to set up. Let's go under job setup. Our machine is going to be a Shapeoko. Doesn't really matter. It just changes the footprint of our canvas so we sort of know what our material needs to fit within. List tools, I'll pick a tool later. Job type is 3-axis. I think flip job will actually generate both sets of toolpaths I need. I'm going to hold off on that for now, so we'll stick with 3-axis. Define stock, did that. Program 0. I am going to do something a little different. I'm going to set my 0 to the middle top of the stock. This just gives me a nice, easy reference that I can work out later. And it makes it easier to flip things. I'm going to machine 2 locating features using Carbide Create, and we'll just go through that real quickly. It's just basically I got to keep the center point in line on the machine. So when I flip it over, I think I'm going to flip it long ways, hot dog style. So when I'm going to set my 0 right in the middle. And so when I flip this over, this needs to be on the same spot on the y-axis once I do that. So I'm going to machine 2 circular features here and here. That'll be in line with my origin, and I'll set that up in Carbide Create in a little bit. First things first, let's get that machined out. So center for my origin, and let's see how that looks. It's about what I expect. Anything else in the menu? You can sort of just march through these and figure out what you need to do. Retract height, above stock. I like to cut it a little closer, so let's go 1/16 of an inch. And then max depth. So when you're machining a 2-sided thing, if you reach a point where there's nothing else you can reach from one direction, there's no point in machining any deeper. So when I'm machining in this setup, the end mill is going to come down from the top, and it's not going to be able to touch anything that's with an overhang over it. So I really don't need to machine beyond the halfway point, it looks like, for this setup. Now, when I flip it over, however, the bottom of this slope down here is actually past the halfway point. So in order to machine that, I'll have to overshoot the halfway point just to establish these surfaces. That's not a big deal, but for the first operation, I'll just machine down to the midpoint, and then I'll shoot to maybe 75% on the reverse side. You want to get these as close as possible to each other because when you're machining from this way, Once you pass the halfway point, you're machining away a lot of air, which is just wasted time. So ideally, these two, when you're machining from this side and this side, the depth of cut would, the total depth of cut would line up pretty well. Um, but I'm okay with this. So, all right, banana, concave, down. Let's make some toolpaths. So I'm going to do a roughing toolpath with, let's, I guess I could do everything with an 1/8 inch end. That should actually work okay. Um, Let me edit this tool just so I can set my speeds and feeds automatically. I'm not actually gonna, well, yeah, I'll keep the automatic speeds and feeds for now. I will override them in the toolpath. So, ball end mill, I want that. My feed rate, wren shape. What do I want to go at? Let's try, wren shape is easy. So let's start at 150 inches per minute. That way I can override this 200% to the max feed rate. Actually, the max feed rate here on this machine right now is 10,000 millimeters per minute, so it's about 400 inches per minute. So I'm actually going to start at 200 inches per minute so that if I get really impatient, I can max out the feed rate of this machine. Plunge feed rate, 35 is fine. Any more would actually be kind of scary. Step over, let's go a little higher. Let's go 65, 70%, 65. And because this is wren shape, our step down can be quite generous. Let's go 0, 7. I think we probably, let's go big. We don't want to go home. So stock to leaf 0.03 inches. I tend to think that we can achieve much better precision in the roughing phase in wren shape than you'd think. So I'm going to leave a boundary of just 10,000ths of an inch around my banana. 3D roughing, toolpath shape parallel, mill direction doesn't matter here. We'll keep it in climb. So let's see how this toolpath looks. We'll calculate it. And that looks pretty okay to me. Really, 3 minutes? That's actually pretty reasonable. I love wren shape. Let's not save this yet because we're not done. We need a 3D finishing toolpath from this direction. So go back to toolpaths, go to unified finishing, parallel finishing. Unified finishing just is sort of a hybrid of several. So I'm going to go, we'll keep 200 inches per minute. This might be a little scary fast. I can always step down the feed rate. Step over percent for a reasonable but not like super smooth finish. I like about 12%. If you want something nice, go to like 5 to 7. And if you're super duper picky, I'd even go down to 3 or 4% step over. For a demo like this, let's try 10%. Let's see how it looks. And then step down for the more vertical faces. Let's go 8 thou. Threshold angle 45 is when it switches over from the parallel to the waterline finishing. Let's see how that looks. So I'm going to disable the roughing. 3 minutes for that. Should be pretty good. Yeah, let's roll with this. Enable both toolpaths. Let's hit save. I will save this to the desktop like a filthy casual. Banana op 1. Oop, wrong post processor. So where is it? I wonder if I export it again. So I was rushing a little bit here. Save as type, Carbide 3D. inches.nc, banana up 1. I was looking for a post-processor selection like in Carbide Create, but Meshcam does it a little differently. So we've got banana op 1. Let's do op 2 while we're at it. So I'm going to have 2 pinholes on this side. So I'm going to flip it along the long axis. So when I'm machining from the other side, I got to make sure that this is concave down, that the banana is concave that way. So let's do that real quick. I'm going to save this also, just in case my computer crashes, and if I lose all this work, it's going to be truly, truly emotionally debilitating. Banana example, save that. All right, so I think if I change my job setup, job type to flip, it'll actually do this for me. I'm just going to do it manually because I actually don't want symmetrical machining from both sides. I need to change the depth of cut of this from the other side because of this undercut. So I'm just going to flip my model about the x-axis 180 degrees. And that was probably a mistake. All right, so I'm going to undo that. Because what I forgot to take into account was the translation that I have in this part. So that was almost really bad. The margin around my piece is asymmetrical, so I have to make sure that's reflected when I reverse this setup. So in the y-axis, I should probably write this down. Wait a second. That's better. Let me make sure there's nothing. That's as far as I can undo. All right, so in my stock, I have been betrayed by this software. It's showing my margin as 0. Why is that? Maybe I didn't actually adjust it. Hold on. Let me reload this program. I just want to make sure that there's no lateral stock offset in this. So from the top, I should have, why is it showing 0? So this isn't, all right, we'll roll with it. There might be a little bit of an offset in this when I flip it. I'm going to keep this as reference. And we'll see what happens. So we're going to rotate this. We're going to flip it about the x-axis 180 degrees. And I'm just going to eyeball the alignment. So let's get our stock back to 5 by 3 by 1.029. And apply that. Let us then center our banana. Why is that being weird? Fixed stock size. Right. Center X. Okay, this is strange. So I'm expecting the banana to be centered in the stock volume that's represented here. My 0 is set correctly, my banana is not. All right, we're going to switch back to this one. We're going to do this as a two-sided job. and work that way. So set job type, flip jig. Let's go program 0, center. So this is assuming I rotate it like that. All right, this will actually probably work out much better. Let's check our toolpaths. Did this not save any toolpaths? That'd be a huge bummer. Since I can't change the max cutting depth independently, I'm just going to overshoot. Let's go 0.75. That way, when I machine from this side, I get past that overhanging portion. So let's go roughing. Ooh, we got to redo all of this. Okay, that's fine. Feed rate 200, plunge rate 50, RPM, who cares? Step over percentage-wise, let's go 70. Let's be bold, let's do 75. Step down of 0.09 maybe. 3D roughing, parallel, climb, 0 1 inches stock to leave. Top setup, bottom setup, great. Now let's do the unified finishing. Same 1/8 inch end mill, feed rates 200, plunge rate 50, RPM, don't care. Step over 10% and step down 8 thou. Okay. Let's calculate this, see how it looks. That is the top setup, bottom setup. Well, looks good to me. Let's save them all. Banana again. I think I should save both separately. Nope. So this is banana bottom, hopefully. We'll find out. Let's actually just say banana up 2. Up. This is what happens when you use an unfamiliar keyboard. We'll delete the original banana up 1. We will call banana again. Banana up 1. All right, so this should conclude what we need to do in MeshCam. Supports might be throwing off the whole stocking. I can retry this later. Actually, let's try that. Let's see what happens if I remove the stock and then I re-center or try and flip the setup. So I'll delete this existing supports, hit OK, hit done, no supports. Let's rotate this in the x-axis, 180 degrees, and then redo the stock. 5 inches by 3 inches by 1 inch. Hit OK, and yeah, that is centering itself much better. Okay, so note to everyone out there, if you have stock supports modeled in your setup, it will affect the calculated margins around everything. But we don't need to touch the banana anymore. Let's go into Carbide Create. Ignore the little wasteboard surfacing toolpath I made up. We'll do a discard everything. So I want to create a toolpath that will machine 2 holes here and here. They will be, let's say, 4.25 inches apart, and they will fit 1/4 inch dowels. Probably can't see that, but trust me, there are dowels there. So these 2 guys will go into machine pockets here and here. I might have to dial in the fit a little bit, but I will try and overshoot the holes just a little bit. I'm okay with these pins rattling around a tiny bit in there. Not the end of the world. This is just a banana. Um, so I'm going to say width of my canvas will be 5 inches. Height will be 3 inches, just to reflect my stock. Stock thickness doesn't really matter here, but I do want to make sure I am zeroing off the top of it. Toolpath 0, I'm going to go center. This is a uncommon choice, but I think in our case it'll work. Machine, I don't really care. Behind the scenes, under the hood, it does basically the same thing. Retract height of 0.05 inches, document background. Let's make sure that's a nice, even, it'll divide evenly. Half an inch seems fine. I'm actually going to go 0.25 inches. And then let's fit to window. So this is a representation of our stock. I'm going to put a circle. Right, I don't want this to snap. There. And I will duplicate this once I set it up. So this circle, I want it to be radius 0.12. Now I do want to overshoot this a little bit so the hole is a slight free fit for the pin. From sort of just experience from guessing around, I usually factor in about 2 thou of negative radial stock to leave, so accounting for backlash, deflection, whatever. So I want to overshoot the radius by 2 thou. So instead of 0.125, I'll do 0.127. That should give me enough wiggle room in this hole. So that's one. Control C, copy. I will drag it by the center and move it. I'll use the move command just to guarantee that the center point snaps to, I turned off snapping. The center point, let's try again, snaps to the grid. Perfect. Okay, so these two holes will be machined probably before I do the banana machining, so that when I flip these over, I can run the same toolpath to machine the holes one more time directly into my wasteboard and just stick the pins in there, and this will flip over and index on that. So how deep do I want to pocket these out? I'll select both of them, contour toolpath, pocket toolpath, using probably, do I want to use the 1/8 inch? Yeah, I really don't want to change tools. So we're just going to keep using the 1/8 inch end mill in here. I'm really going to leave the ball end mill in there, but I'll just plug in the 102 as a surrogate. It'll be close enough. It doesn't matter. All these toolpaths are calculated based on the tool diameter. CNC is not going to know the difference. So select 102 end mill. Depth per pass, 45 thou is pretty good for MDF step over. Let's keep this pretty small. I want to make these holes just a really nice gentle toolpath to maximize the precision of these. Spindle speed, feed rate. Again, for really small interpolated holes like these, CNC is going to be drilling in holes and it's going to be accelerating a lot. So I actually want to slow down the toolpath just to reduce any vibration in the belts of the machine or the frame or just the tool expanding the hole more than it needs to. So I'm actually going to back this down to 40 inches per minute. Let's see how long this toolpath will be. Oh, max depth. These pins, I want them to fit at least halfway down, accounting for the radius of the ball and mill I will inevitably put in there. These pins are 3/4 of an inch long, so I'll actually go down, let's go 0.42 inches. That should be enough to account for the radius. There's a slight bevel on these, so these should fit into like the bowl nose of the radius that the ball and mill leaves behind in the pocket. Pocket toolpath, let's call this pinhole maker. Okay, under 2 minutes. It's actually going to do 2 passes. Little tiny circle, then it goes out, slightly bigger circle. I'm okay with that. So let's save this toolpath. And we will call it the indexing holes. There we go. So we got 3 toolpaths now. Let me make sure I had the correct post processor selected. Check. All right, let's get machining. We're halfway through the live stream. Perfect timing. Get these pins out of the way. Let's zoom out a little bit and check my focus. I gotta go back and forth to my monitor so I can check focus between here and it's a mess. All right, so first things first, I'm gonna load up an 1/8 inch end mill here. So hopefully I have one. I'm looking for 101, the 1/8 inch ball nose. Some collet wrenches. So, do we have any questions in the chat? I'm going to take a gander over there in a second. But if you have any questions, let me know. We'll try and answer them for you. For now, I need to change out the collet to the 1/8 inch version. So, 1/4 inch goes out, 1/8 inch goes in. There's always a little bit of dust that accumulates in there, so just make sure you knock it out. Maybe like use a vacuum, use a cloth if you really want to. You don't want to let that dust migrate its way up into the spindle, because that'll just affect how well the tapered portion of this collet seats in there, and that'll affect your run out. Let's get that not quite crushing the collet, just sort of loosely there. Get the end mill in. I like to just hold my thumbnail about 1/2 inch down just to make sure enough of this tool gets seated in the collet. And then start locking that in. So for something like this, just you can push against the wrenches themselves. A couple fingers of pressure for an 1/8 inch end mill is usually okay for me. If you're cutting aluminum, I crank down on it a little more. If you're getting problems with the end mill pulling out of the spindle, just wipe everything down with isopropyl alcohol. Make sure there's no oil or anything that's making it more slippery. I'm just going to do a visual inspection here. I think we have enough stick out. We might have an issue with the brushes on the boot meeting up. So where this ends, I think we'll be fine. I don't want this brush to crush too far down to the material. On the sweepies, we've got a really soft brush that can compress a lot, but we're going to get really close to that limit with such a short tool cutting over 1/2 inch deep into wren shape. Yes, my override is at 200%. Robert is very attentive. I will reset that first thing I do when I start the toolpath. I'm probably going to forget now that I say that, but let it be known that I intend to reduce my feed rate override to 100%. So to find the center point of this, which is my origin for these operations, I am, let's do the old find a diagonal trick. It really doesn't matter what it is for the first setup, because the subsequent operation will be relative to the pinholes. So, in fact, I should probably just eyeball this to make a point, but let's do this as properly as we can. to work hold this, we have concave down on the first op, I think. I could probably use 2 corner clamps here. Let's see what I have in the drawer. Got an assortment of gator tooth, tiger claw clamps. Not enough machine screws to be able to use all of them. So, but wrench shape cuts really easily. So I'm gonna say if I just hold down in the corners with just a little bit of overlap, that should be enough. So I think there-ish and there. I'm going to shift this over so I have 1 screw in line that I can sort of just position the clamps with, and I need a little bit of a standoff there. So let's hope these are long enough. Should be. Without that is a borderline. So let's go with the 1.75 inch. Let's see. I don't know if these are going to bottom out into the MDF baseboard underneath the wasteboard, but we'll try it. So I'm using 1/4 just because I have a non-metric threaded inserts in here, but 4mm 4mm Allen key works for both metric and imperial. So I'm a big fan of the 1/4 M6 similarities. We'll just get that loosely tightened down. We'll throw down our second clamp here. Nose of the clamp. The good thing about the aluminum clamps is that if you nail them, nothing catastrophic should happen. The tool might actually survive and go straight through it. So I don't want to crush too hard on this wrench shape because it is basically a super dense polyurethane foam. So it will actually indent a little bit, like I can sort of get some flakes of it off with my fingernail. I just want this tight enough so that I can sort of shake the table without this piece moving around. All right, 4 clamps down. Let's set our 0. Okay. So before we do anything, because we have a bit setter, and I changed the tool, I gotta re-zero everything. Otherwise, I have to load a new tool and let it go through that touch-off cycle so it knows the offset of this tool. Otherwise, when I jog around and I set my 0, it's not going to be correct. So please insert a tool, continue. Let me see if I can blow up this window a little bit more just because that's more interesting. All right, and now we can jog to our stock. Let's go jog, increment, fast. And I'm just going to eyeball it on the X. X as in the cross, not the actual X axis. Let's switch to millimeters. And down just a little more. I'm going to switch to drop the increment down to the second smallest one, so 0.25 millimeters. Bring it down a little more, and then just inch this over in X and Y. X and Y look good to me. I'm just going to bring this down till it just barely touches the material. And honestly, I'm okay eyeballing this. The margin of error is going to be smaller than probably the margin of error when I flip this, so it'll be good enough. Remember, it's just a banana. So set 0, 0, all. Done. So I think we're ready to run a toolpath. I'm going to do the indexing holes first. I'm just going to check through this. eyeball it, make sure it doesn't look too crazy. All right, let's load that. Indexing holes. Okay, size. Looks like it's under 5 inches. Small, X bounding box, Y bounding box. All right, everything looks reasonable. Start job. I will remember to reset my feed rate. And let me, I might end up just holding the vacuum hose nearby for this. So I'm gonna hit start. It's gonna go through its, ask you to load the right tool, ask you to touch it off. And then after this, I'll drop the volume, grab the vacuum, we'll machine the little holes. I'm going to preemptively zoom in on the cut for you guys. And let me check the focus. I think it's pretty close. So yeah, we'll go manual on the vacuum. I will duck my volume for you guys, and let's cut this. And we're back and everyone survived. Before we proceed, we should check the fit of these holes, make sure that the dowel pins go in there well. That's, all right, it's a little loose. I probably overshot the diameter that I needed, but this will do just fine. They look like they're sitting in more than halfway, so that's good. I kind of wish someone were downstairs to throw a brushless sweepie at me. I think these are epoxied in there. I can't pull out the brush. You know what? Let's just let me take a look at this. We can. I'll run without the boot. I'll just load the dust hose in here. I might even run downstairs to grab a dust boot. But let's start the next operation. Load file, banana, op1, open. Start job. See, I'm going to zoom out just a tiny bit. Let's get a little more context. Insert tool 1, check, zoom. And we're ready to go. So I will duck my volume again. I'm going to make sure the first pass goes okay, that we're not in danger of crashing into a clamp. And then after I verify that the remaining toolpaths should proceed okay, I'll run downstairs, grab a better attachment, basically a brushless sweepie to throw on here, and continue cutting. So here goes nothing. If you have any questions, again, throw them in the chat. I'll also be communicating to you guys through the chat since I can't really talk over the vacuum plus router. So feel free to chat away or chat amongst yourselves. All right, so we did not crash, but this is getting uncomfortably close to the collet for me. So I'm probably going to reposition this either here or here. I'm thinking I might put a clamp here and then throw a tiger claw here, just because this is getting super dodgy for me. So, just for my own sanity, I'm going to do that. Reclip my microphone. Um, there's also a lot of static buildup on this. All right, let's do some live reconfiguration of this. So as long as we keep 2 clamps on here, at least 1 good clamp, this should be fine. I'm trying to think of how I can do this without messing too many things up. Need more clamps. So I'm going to try and remove this clamp without the whole thing rotating. If it does pivot, whatever, we'll just consider this side finished, and then just machine the other side. We're doing it live. So let's see. I'm trying to think. My retract height is a little low for my tastes too. I think if I move this probably here, I'm trying to decide which corner I want to move this to. I'd rather have these on opposite sides of the stock. I'm thinking here might be my best bet. We could also, this might actually work better, use the grub screw feature in the clamps here. So I'm going to do a little bit of a reset. Let me zoom out more for you guys so you have a little more context about what's going on. All right, so big long screw goes away. Make sure this clamp is flat. I like this one. So set this up like that. And we'll set this guy up back here. Actually, we'll go, yeah, this is good. Over here. That was too short. All right, so I guess this can be a little plug for the gator tooth clamps and their angled work holding feature. Get that as close to the stock as possible. Lock these in there, and then throw a grub screw in there. You can use the shorter ones, but this is, I need I think a 3mm for that. Let's get that loosely in there. And so this will actually dent and bite into the wrench shape, which is fine, but it's also going to be super low profile and not cause a potential collision. That move did not like that. Got to sort of move these in unison. Since we haven't done the finishing toolpath, this side should still come out smooth, but these alignment holes may not be perfect anymore, which honestly I don't care about. Again, this is a banana. But if you're actually going to machine something like this, probably machine those indexing holes last. All right, so shouldn't have a collet collision. This is still a risk. I could probably use these screws, and you know what? Let's change that out as well, just to be safe. How are we doing on time? We're going to go a little over. It's okay. It'd probably be safer to just stop the execution of this toolpath and move the gantry out of the way. The thing to be aware of when you're working around this is that don't run your hand across the cutter because that will slice open your hand really easily. So just be super aware when you're underneath the spindle that sharp pointy things are there. All right, so this is the way we should have set things up to begin with. We're going to use slightly longer screws there. And we're going to throw this guy back here, and I'm going to feel so much better about this, this toolpath. Because I don't know about you, but I was getting real nervous there. We were at one point, the bottom of the dust boot was about a millimeter above the clamps, which is not good. Normally I'd probably use a longer 1/8" end mill, but I'm just working with what we have in the Carbide 3D inventory. This is what I happen to have on hand. Okay, that's sufficiently tightened down. Let's throw in the grub screws. I'm going to tighten this one first since this one is right up against the stock, so any movement or deflection should be pretty minimal. I'll tighten these up in unison now. And then 3mm just to really make sure that's secure. Saw a little bit of movement on this clamp. That's because I put the screw in basically here. Can't see, like on the far side of the clamp, so it's a long moment arm. You can really tighten these down. If anything, the MBF will complain. Not a big deal. Let's retighten that. Check. Tighten that. 3 and 4. Still secure. Good. Let's clean up, and there should be enough clearance for that tool to finish. We'll find out. There could still be a crash. All right, I will duck the volume, restart the router, restart the vacuum, and we'll see what happens. So it's prompting me for a tool change now, even though I thought the finishing tool was the same as the roughing tool, but we'll go with it. Um, should be a pretty benign thing. Um, we are at the bottom of this toolpath, like 1 or 2 millimeters from rubbing the collet against the stock. So this is just barely working out. All right, muting myself again. All right, we're just gonna fast forward this because I guess my vertical step over was a little too small. So this finishing toolpath is actually taking an obnoxiously long time. So I will show you the state of this now. I will machine the receiving holes for these indexing pins, flip it over, maybe do the roughing up. Uh, but after that point, feel free to step off whenever you want, because at that point, I pretty much demonstrated the whole process. So there's not much left for you to see other than a completed wren-shaped banana, um, which I'm sure is not the most spectacular thing in the world. I will also refine my work holding situation, perhaps. Um, so this is the current state of the banana. That's not in focus. Uh, Current state of the banana. Still some super rough lines. It was finishing super deep all down here, so you can't really see it. But that's the texture after the roughing pass. So I am going to get these clamps out of the way and then mill the matching holes for this, flip this over, and then just start the roughing process. And if you stick around an extra like 10 minutes, maybe you'll see the banana held on with tabs, or what'll be more likely to happen is the banana goes flying out of my stock and impales me, thus ending the Carbide Office Hours live stream series. All right, clamps out of the way. Honestly, I could probably leave these, not a big deal. But since I'm machining into MDF, I do want to keep the dust boot on. So let's get these out of the way. So I'm going to jog back to the X and Y position where my run shape block was. It doesn't matter where, but I like this spot because the line of the along the y-axis of where this was pretty good, so that when I machine in indexing pins, indexing pin holes, I keep sensing that I'm not entirely in focus. Is that better? I think that's better. The indexing pin holes are not at risk of being on top of a threaded insert, so this is a pretty good location. So I'm going to keep this point as my X and Y 0, but I will re-zero on the wasteboard. So I can use that whole boring operation that I did here directly in the MDF. I will have to step down my feed rate perhaps a little bit because I'm pretty sure I designed that for wren shape, but we'll see. Actually, no, whatever. Let's roll. Bring this down 1 millimeter at a time. And so I could wiggle a piece of paper, but what I tend to do now is just look for the just a sliver of light to disappear behind the end mill, and that'll do it for me. You can gauge the thickness of a piece of paper pretty well. I kind of do this for leveling my 3D printer too. It's probably sacrilege. I don't use a shim. I just eyeball a gap that looks like the diameter of a extruded filament. So I'm going to set that as my Z0, call that done, and then jog up so I can throw the brushless sweepy back on. And then from here, let's go back. Let's load our indexing hole toolpath. Okay, start that. It's okay if nobody else answers. I'm going to drop my feed rate to 80% to start off with. Start the toolpath, let it do its tool probe. Banana puns. All right, and we're good to go. It is super, this hose is caked with wren-shaped dust. Um, this stuff is super staticky. But let me mute myself and let me start this toolpath and hopefully not crash the machine. And it looks like we may have had a static related disconnect. So shouldn't be an issue. We'll just power cycle the machine. Normally what you'd want to do in this situation is maybe ground out the vacuum hose. Um, I'm running a Festool dust extractor. However, I'm using a fine hose, which is not static dissipative. So that charge that I was talking about, the wren shape, making everything super staticky, is potentially an issue. Let me duck my audio just for a second and then vacuum this up. Oh yeah, it's going to prompt me to insert the right tool. Okay, let's check the fit of the dowel pins. It's actually pretty good. So there, banana was concave down, and we flip it this way. So that is our stock located. We know the X and Y coordinates are lined up the way they were before. I just need to re-zero the Z on this top surface and we'll be good to go. I do need some work holding on this, so I'm going to go back to the gator tooth. Not a fan here of the fact that my hole spacing is lined up such that they fall like, actually that might work. We'll see. It's really close to not being able to accommodate the 420 screws. Looks like we're going to be okay. So we'll throw a pair here, and I will do a redundant pair for safety, and we'll get the grub screws back in here. These grub screws are in the way because I need to move the screws all the way up to almost the stop. A little bit of wren-shaped dust in there, hopefully I'll just thread through it. Maybe, maybe not. Oh, it's actually, I think, a piece of MDF from when I was surfacing the wasteboard. And where's my last quarter 20? Could have sworn I had an extra nut. Must be getting old. I'm misplacing things. Just use one of these, I suppose. For that, I need a 4, 5 millimeter, or I'll just hand tighten it and call it a day. I think it's still close enough that 5 millimeters matches up to the, sort of. The metric imperial interchangeability stops at 4. It should be secure enough though, even with 2. So let's get our grub screws back in. How's the chat doing? You guys still good? Let's see. So long-term fix to the static issue would be ideally getting a vacuum hose that's grounded. You could do it yourself, either by wrapping bare copper wire around the inside. I think someone said you should do it on the inside or the outside. But either way, just to conduct, to even out the charge on the hose so it doesn't build up a high charge in one area. The other thing for EMI and devices like routers near the end of their life, they tend to get a little sparkier inside. If you look inside the router, sometimes you'll see like little arcing as you turn it on and off. As the brushes wear down or the router ages, sometimes you can get EMI issues like that. But if you hook these up to a good quality AC isolator, we've actually found that that will eliminate a lot of device-related disconnects. So I think we are pretty good and tight. You can even see here the grub screws digging in from the other side. So let me make sure I set the Z0 correctly. So we're going to go fast down to near the surface, try not to gouge the part. Switch to 1 millimeter jogging. Switch to 1/4 millimeter. Oh, I'm already touching. That's fine. Just another thou or two. Good enough. And then set the 0 out Z. And then I think we're good to go. So load new file, banana op2, open, start job, feed rate override back to 100%, start. Throw the sweepy back on now. Resume. Seeing you back in there. And let's get to cutting. All right, so I've just killed the toolpath after the roughing because the finishing takes way too long, and this should be plenty good enough for you to see what we've accomplished in this hour and a half. So, I present to you a wren shape banana. Um, it actually matches up really well. I wonder if I can pull this out. Um, Ideally, a serrated blade would work better. But let's remember, kids, 90% of workplace injuries are caused by improper knife usage. So be careful. Take responsibility for your dumbness. Try not to really force things with blades. This is probably not worth pulling out. It's one, that's two. I'm just going to score all of these actually and then just snap it. That should be good enough. Should be a clean enough break for what we're doing. Yeah, that's in focus. And let me score this side. One side. Other side. There we go. That is a banana. Thank you all for your time. And I think I can finally go enjoy a tasty beverage. Enjoy your weekend, guys. Thank you for tuning in. Thank you for sticking around for an hour and a half. Let me know if you have any last minute questions. I'll be in the chat until the YouTube kicks us out. Should be a couple minutes. But if you have any more questions, that is how you do some basic two-sided machining. Don't forget to check out our community challenge. It ends on August 2nd, I think. August 2nd, midnight PST. Win up to $200 for the Carbide 3D store. So yeah, worth your time to take a gander. And I hope you all have a fantastic weekend. So thanks all for tuning in. Enjoy.